Alright, so let us continue talking about infinite sequences and finite sequences as we have been doing. So now I want to talk a little bit about the sum of a sequence, or what happens when we add it together. Ignore that. Or what happens when we start adding stuff together. So let's say, for example, 1 plus 2 plus 3 plus 4 plus 5, all the way to, say, 1,000. Okay? Let's face it, you could do this relatively quickly if you knew how to do this. If you knew how to do this with a simple shortcut. This is not actual punishment. I'm sure your teachers may have tried to punish you by saying, add all numbers 1 through 1,000. And if you're real smart, you would notice that there's a pattern that goes on here. And this would be, you can simply look at this sequence and say, okay, you want to add the first 1,000 terms? Okay, there's 1,000 terms. Divide by 2. First term is 1. Last term is 1,000. That kills that 500 times. This is 1,001. And then you end up with 1,001 multiplied by 500. Which gets you 500,500. Okay. Now, there is a general way to write this kind of idea. And the teacher did punish the guy named Carl Friedrich Gauss. His teacher tried to punish him by doing something similar, only instead of going to 1,000, he had him go to 100, and so now I will show you how we get this rule, kind of, so to speak. Because right now it sounds like I'm just talking out of my tail. So let's show you how we get this rule. Well, first of all, we know we have two ways to write a sequence. So kind of, we have A1, A2, A3, dot, 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 A7. Or we can write it in decreasing order. A1. Right? We can order a sequence in any way we want. We can order it either frontwards or backwards. Doesn't matter, as long as we go to an end. And understanding that principle, we'll look at the page in the textbook. It goes over this principle. Okay, 694. And if I was to add all of these together, we can define this as a sum. The sum of n terms is A1 plus A2 plus A3 4 all the way to A sub n. Right? Now, of course, I can rewrite every little term here in terms of the first term. So that's what we'll do here. Right, so this ends up being A sub 1, A sub 1 plus D, and this ends up being plus sub 1 plus twice d plus all the way a sub 1 plus n minus 1 times d. Now, you may think that's all there is to it. Not quite. I could also write this in the same way, in of course our decreasing order. The same way to write it sorry. Alright, and now in this situation, I'm going to rewrite it in terms of subtracting the difference instead of adding it. Okay. As so, a sub n plus sub n minus twice d takes the same form as the others. It's the exactly same form, just in different form. Okay. Now that I know that, I can add equation 1 and equation 2. So I can add these hideous, ugly things. So, if you're noticing, what happens when you add, the common difference goes away. Everything involving the common difference goes away. And then, all you end up with in these situations is a sub 1 plus a sub n, because the common difference is gone. So you end up with so on and so forth. And there's only n amount because we're limited to a finite sequence. Okay? So that's how we end up with n times a sub 1 plus a sub n. And of course, since we added these two equations, this is twice the sum of n. And divide by 2, divide by 2. I end up with the definition, I end up with the formula for the sum of an arithmetic sequence, which I'll write on the bottom. Oops. Did not need to skip pages here. Did we change the color? So we end up with the formula an arithmetic sequence and very important you recognize it's just sequence, not the series form, although you can kind of interchange them. So we have A1. So your sum of the arithmetic sequence is equal to n, how many terms you have, times the first term plus last term divided by 2. Okay. From this point, we'll come back with the properties of the sums.